This video is going to show how to create a crosstab table and from that do our chi-square analysis as well as calculate a Cramer's V. Notice that the study that we're using here, this data, was conducted among fraternity and sorority students regarding their political affiliation, and the question is we want to determine whether there's an association between gender and political party. We have responses from males and females listed in columns A and B, and we need to convert this into table data. So I'm going to use a pivot table to allow me to do that. And I will select all of the data in the range by going to the bottom of those two columns and capturing that address, and also will output to a new table. And I'm going to select males and for one table, and the number of males, the value there, we see we have 22 who consider themselves to be Democratic, 1 to be Independent, and 27 to be Republican, for a total of 50. Now, going back to the original data, we're going to do the same thing for females. Insert, pivot table, data range. I'm going to pick up the female column right here and put it on an existing sheet, and in this case I'm going to put it on the sheet we just calculated right below that point. Say OK. Now bring the female count label and count in, and there we have it. So now we have our table. I'm going to do a copy and paste in order to break the links that currently exist with this particular pivot table, each of these. So I'm going to do the whole sheet. I'll do a copy, and then I'll do a paste of values. Notice that the blue disappears. And now we have the raw numbers that we need for our table. I'm going to clear out just delete some columns and some labels in order to clean it up a bit. And now we have our table. And so we're ready to go. I need to add a total row value right here for each column. So we'll do that and grab the appropriate value. Slide all the way across, and there we have it. So now we have our data listed here. Just do some cosmetic work. Here we have our table data, and we can see that we have males, we have females, and we're ready to do our analysis. Now we need to calculate our expected values, and keep in mind that our expected values are going to be row total times column total divided by table total. So let me add some labels just to keep us honest, and we'll copy these up here too. This is just for cosmetic purposes. It has nothing to do with our analysis. Now we're ready to put in our value, and I'm going to set it up as a formula that I can then drag and autofill for each one. So starting with row total times column total divided by table total. Now these are all relative addresses, and I'm going to add some dollar signs which will make them absolute. So starting with the table total, I put my cursor in that cell address value, and I simply hit function 4 at the top of my keyboard, and it inserts my dollar signs. Next, I go to the row total, and we want to keep it referencing column E, so I'm going to put a dollar sign in column E, and I can do that by hitting that F4 key, that function 4 key, multiple times, and it will put the dollar sign where I want it. The same thing is true for row 7. I want to anchor row 7, so I'm pressing the F4, and now I have a dollar sign in front of 7, dollar sign in front of E for E5, and then double dollar signs for the table total. So I'm ready to go. And now I'm going to simply drag it and drag it. And now we have our expected values right here. Let's do some cosmetic work over here. There we go. And now I'm going to total up just to verify that everything is calculated correctly. So 50, 50, and 0, because I don't have any totals here, but I will shortly. Doing a sum value here, coming on across, and there we have it. So my expected values here are the same as my actual values here, and now I'm ready to do my chi-square test. Remember that it's a built-in function, and what it will give us will be the p-value. So that particular function I'm going to locate right up here under Insert Function. I'm looking for chi-square.test. Chi-square.test. Notice that it has two arguments. It has actual range and expected range. So since we've already created that, we're good to go. Here's actual range, not including totals. Expected range, again, not including totals. So we have B5 to D6, B10 to D14, and we're ready to go. And there's the p-value. And so immediately, based on our knowledge of p-value, if we're using an alpha 0.05, we already know that the relationship is not significant. There is no association. But we need to go ahead and finish our analysis. So let's put some chi-square test statistic value right here. And to do that, I will insert chi-square.inv.write, RT, and that will be my value. The probability will come from the p-value we just calculated, which is the probability of that t-stat, and the degrees of freedom. Remember, degrees of freedom is rows minus 1, so 2 minus 1 is 1, and times columns minus 1, so we have 3 minus 1 is 2, 2 times 1 is 2, so I have 2 degrees of freedom. And we see that our test statistic value is 4.32. Now, let's go ahead and create our chi-square critical value, and we're going to use the same chi-square.inv.rt, only in our probability we'll put alpha right there with our 2 degrees of freedom, and now we have that. And so we see that our critical value is 5.99. We see our test statistic is 4.32, and our p-value is definitely greater than 0.05, and so we would reject the null that what we observe is what we expect. Now, just for kicks and giggles, we'll come over here and manually calculate it. So remember that our formula says our observed value minus our expected value squared divided by expected value will give me my chi-square stat. So I'm going to simply copy, and total the whole thing up. So let me do that. I'm going to summarize all of those values right there. And notice that the sum total, doing it manually, is exactly the same as the subtotal, or as the function total that we get from the function. So it verifies that we haven't made any mistakes. So we have the p-value of our test statistic, our chi-square test statistic for this table. We have our test statistic literal value, and we have our critical value. Now, one more process we need to follow, and that is to calculate Cramer's V. And notice that Cramer's V is equal to the square root of the chi-square value divided by the number in the sample, and that value is divided by the minimum of the row minus 1 or the column minus 1. Well, in this case, we know that we had 2 rows minus 1, so it's simply going to be 1. So square root of chi-square divided by n. So we'll hop back over here, since this is where our chi-square value, and I'm putting Cramer's V right here, and it will be equal to the square root of, and now we want it to go ahead and calculate chi-square divided by table total. Remember, that was n. And we have our Kramer's V value is equal to a 0.2. What that says, Kramer's V ranges from 0 to 1. And since it's a very low value, it confirms that there really is no relationship. If we had had a significant relationship between gender and political party, it's very likely that this would have been a higher value, and the closer the Kramer's V gets to 1, the stronger the association between the two. So there you have crosstab analysis, calculating the p-value of the test statistic itself, and the critical value, as well as Kramer's V.